All right, so now that we have a lot of our individual pieces kind of created, we want to start puzzling it together, right? So we're going to build some rooms. I'm going to kind of build out our hallway here. So in computer science, let me just hide this. We're going to have something along the lines of this. Here's our entrance. And then maybe have one little hallway. And then here's the room we're in here. And it's kind of an extra big room, maybe. We'll leave it like that. We'll leave it like that. What's this? This is what the department looks like. You walk in the door here, you go a little farther. The assignment was not complicated, it was open-ended. You could have made any dungeon you wanted. All right, so we're gonna make some rooms. All right, so let's go ahead and let's create these rooms. And what I'm going to do is I'm going to go ahead and actually build these inside of a dungeon. So that what we do is inside main, we'll just say we'll create an instance of our dungeon, and our dungeon will go ahead and populate itself with the rooms and the right kinds of exits and that kind of stuff. Later on, we could have it read in from like a text file, JSON file, something like that, but we're just going to hard code it for now. But we want to keep main looking pretty clean if possible. All right, so I'm going to go ahead and refresh this since I think we've had some of those issues in the past. All right, so inside of dungeon right now we have a collection of rooms that's going to be equal to the max number of rooms that we can have. The starting room is going to start off as null, but we're going to go ahead and we're going to fill up this guy. So we're going to say set up CS department. All right, now maybe you could say that this isn't quite the place to do it. In fact, actually, we're not going to do it here. We're going to create a function specifically for the CS department in case you wanted to create another thing. So we're going to say this is going to be public void populate CS department. So we kind of have a special function inside of dungeon that once a dungeon is created, we can tell it to go ahead and populate the CS department, and that function goes and builds out the CS department in case we wanted to build other custom dungeons. So inside here, we want to go ahead and create all those rooms. All right, so we're going to have a let's see, we can create the rooms. We're just going to do them separate. So we'll say room R1 is equal to a new room. And when we build rooms, what do we have to provide it? Just the name of the room. All right. So why don't we call this guy, we'll call that guy entrance. Room R2 is equal to new room. And I'm going to steal this as like a template. All right, we'll call this guy H1 for kind of hallway 1. So this is H1. This will be H2. This will be H3, H4, H5, and then S118B, something like that. H2, H3, H4, H5, S118B. And then let's go ahead and actually name our rooms relative to those things. This is H1, H2, H3, H4, H5, S118B. All right. So these rooms now exist, but we don't have them linked together. Now, ultimately, we are going to end up putting those rooms into our collection of rooms. All right, because we want to keep track of all the rooms. We don't know how we're going to use that quite yet, but we want to have a collection of our rooms. So I'm going to create another variable up here. And remember, we're going to make all these private. We'll loosen the reins if we have to. And we're going to say current number of rooms is 0. All right, so when a dungeon is first created, we set up our rooms array capable of holding max number of rooms, but it currently has 0 rooms in there. All right, and we don't actually know what the starting room is yet. We're going to go ahead and give ourselves a function private void set starting room. And remind me, what does private mean again? When a field or a function / method is private, what does that mean? Go ahead. Okay, so that means we can only access this function if we are inside the dungeon class. Okay, now why did I make it private? Because I decided, you know what? Since I want to have this stuff encapsulated inside of dungeon, and these are development choices. You could decide you want your code to be organized differently. So this isn't necessarily a right or wrong thing, but I've decided, you know what? Out here in main, what I really want main to look like. Let me just dump all this crap. I want main to look like dungeon CS is equal to a new dungeon. And we'll say that we can have up to 100 rooms in there. That's what I want main to look like. And then maybe eventually I tell the game to start, cs.start. So I want main, this is kind of like the conductor of an orchestra, all right? This is the thing that drives our program. That's why I think I've mentioned I often call this class that has main, and I often call it driver. The online GDB makes me call it main for its magical blah, 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 whatever's. As soon as we get over to Unity, hopefully here the end of next week, maybe end of this week. I kind of want to finish a baseline here and say, we like Java, blah, blah, blah. We've kind of understood the upgrade from C++ to Java. And then we're going to just do a sideways slide into C#, which is the same as Java. We'll just have to like make our uppercase S in string, lowercase s, and a couple of crap like that. But we're going to do it in context of Unity. So everybody will have to get Unity installed. If you wanted to start looking at that, you can go ahead and do that if you wanted to. Just make sure you install Visual Studio with it, because that's what we'll be using. But whatever, we'll get to that when we get to that. But that's the current plan, is we're going to be rolling over to Unity soonish, certainly in the next 2 weeks. All right, so I want to say inside of main, here's my dungeon, go ahead and do the thing. And then maybe outside there, I would say something like dungeon populate CS department. That's effectively what I wanted to do. All right. Now, if we were making this a little bit more general purpose, we might do something like cs.populate and pass it like the name of a file. And then it would go read from that file and build out all the rooms and the exits and things like that. Like we'd have to pick our file, like write our file in a certain kind of format. But this will be good enough for what we're trying to accomplish here. So we're just going to hard code inside of populate CS department, the magical stuff to build the CS department. All right. So when we call populate CS department, we'll go ahead and build out all the rooms. I'm going to go ahead and set the starting room, this dot starting room equal to whatever room was passed in here. And this guy made a private method. So he's only, you could only call him from within the dungeon class. So we're going to go ahead and say, you know what? The main entrance to the dungeon CS is this guy right here. Entrance. This dot set starting room entrance, except that lowercase e, I don't know what it, whatever. That guy. All right. So I'm going to set the starting room for this particular dungeon equal to the room that is instantiated inside the variable called entrance. All right. Now, let me just remind myself how we did exits real quick. Okay, exits, we did directions with destinations. All right, so that means that we're going to have to create some exits here. Go back to our drawing. Go ahead. Well, no, I did, but I thought you talked me out of it and said you wanted it to be like the same as last semester.
Last semester we did have a switch.
Oh, we had source and destination.
That's what I changed it.
Oh, how do we want to do it this time? This other way?
Whichever way you want.
Here's the difference. So here, well, this is the difference. The difference is, will there be a single exit here? That's like a two-way door. Okay, where if I'm going from this room to this room, this guy would be the destination, this guy would be the source. If I'm going from this room to this room, this guy would be the source, this guy would be the destination. Or do we want to have a one-way door where there's one exit leading from this room to the north? There's another exit leading from this room to the south. The way we haven't done it, which is the way I have it set up now. All right. So that means an exit has a specific direction and then the place that it goes. Okay. And let me make sure rooms. Okay, they don't have it yet, but we're going to have to build it. All right. So let's go ahead and build let's just build the first exit for that first room, and then we'll figure out how we need to add that to our room. All right. So we'll go ahead and build exit E1 is equal to a new exit. And we decided exits are going to take in the direction they're going to head as well as where they're going. All right. So this guy is going to head to the north. And where is he going? He's going to H1. All right. Oh, thank you. There. I thought I did have new there. Did I press enter and it corrected it? Oh, well, whatever. Okay. So there's my exit. It's going to go to the north, leading to H1. Now this exit's just floating out here in free space. I have not associated that exit with a room yet. So ultimately what I have right now is, let's see, what's an exit? An exit, maybe this guy. And then of course, exits are in green, right? Yeah. Okay, so this is E1. So right now, this guy's floating out, Ninja. He's floating out around over here, but I need to add him to this room so that this room has that exit. Make sense? All right, so that means I need to teach rooms how to hold collections of exits. All right, so we'll go to, type some stuff. We'll go to room. And we're going to say, okay, well, now a room also needs to be able to hold an exit array. Maybe this guy's called the exits. All right. And he's also going to have to remember how many total exits he has. All right. Now, if we were using a type that was elastic instead of hard-coded arrays, remember, arrays say, you know, I'm going to build this guy capable of holding 4, you know, north, south, east, west, 4 exits. Okay, but in a this first room's only gonna have one exit in it, right? So I'm only gonna be using one of those 4 slots. So somewhere I'm gonna have to remember how many exits have I actually put in here, as opposed to using a different data type. For example, maybe in Java, we would use something called an array list that would allow us to just create an empty array list and add stuff to it, and it would automatically keep track of where it's at. We'll end up doing that in C#, their equivalent of that. I'm not going to do it here. That'll just take more time to introduce that. So we'll introduce the elastic types over in C#. So right now I'm going to have to keep track of number of exits. All right. So when a room is first created, we set the exits equal to a new exit array with a maximum number of exits of 4. North, south, east, west is the possible exits this room can have. But at this point in time, we don't actually have any exits in there. Number of exits is 0. Make sense? All right. But now I need to teach rooms how exits can be added to them. So I need to give this room the ability to add an exit. All right, so we'll write a public function inside a room. I need it to be public because I need to be able to access it outside of this guy. We could have just left the security measure off and then it would be package level. So as long as the stuff's in the same direction or directory, we would have access to it. But we're going to go ahead and say public because we want things outside of the room class to be able to access the ability to add exits to a room. Okay. And what are we going to do here? We're going to go ahead and say this dot the exits at bucket. So where's the very first exit going to go? It's going to go in bucket number of exits. It'll be bucket 0 the first time, then we'll increment that guy to 1. The next exit will go into bucket 1. We'll increment that to 2. The next guy will be in bucket 2. We'll increment that to 3, so on and so forth. All right. So we're going to say number of exits is equal to E. So here's my array. At bucket number of exits in that array, so the first time through would be 0. Go ahead and put the exit that we're adding. Then we'll say this dot number of exits plus plus. Now, realistically, if we want to put a little policing in here to make sure we don't go over 4 exits, if somebody gets a little bit excited, we could do something like if this dot number of exits is less than 4. Do this stuff. And then maybe we can throw an else in there. Oh, thank you. They just won't let me click on stuff, huh? Else, we'll do like a system.err.println. Too many exits. It'll print out usually in red. Did I not talk about system.error? Most operating systems have 3 different streams: system.out, so an output stream, an error stream, and a input stream. So we've seen system.in, we've seen system.out. Are you sure I didn't talk about system.error? You lying? Okay. Yeah. But in any case, you could just put system.out here, wouldn't be the big deal. The reason why you might use system.error for error messages and system.out for things that you want the user to see is for like error logging in operating systems. You can redirect the error messages to like a log file and not capture every single thing that ever spits to the screen. So that's why you might want to actually system.out and system.error will both go to the monitor, but you can choose to redirect those individual streams to different places like an error log file or something. So you could choose your poison here if you just want to have it system.out, that's fine. Okay. But since this is an error, I'd probably put it in system.error in case we wanted to have our big boy dungeon crawler thing here actually have error logging, which we probably will not. But we have the option now, since those things, and some terminals will make the system.error thing show up in red. I have pretty low expectations here of online GDB, but yeah, it is what it is. This goes out the window as soon as we jump into Unity, because seeing things out at the console in Unity actually is not the easiest way to do error checking. So you can try to find stuff in there, but a lot of times what you might do is just throw a giant label out in the screen. And when you want to check the value of something, you literally just write to that label so you see it during your running game. So we made like a 3D Pac-Man last year in VR, where you were playing as Pac-Man and you could hear the ghost breathing behind you. and you're like dodging between the stuff you had to but just for like the countdown and stuff, we had things up on the little labels and whatever. All right, so add exit. Presumably we're going to build our stuff correctly, but we're only going to let them actually add an exit if we don't already have 4 exits. Then we'll let them add the exit. We'll increment the number of exits so that the next time around we put the exit in the right place. We'll scream at them if they try to add too many exits. We're not going to do that, so we won't see that error message. All right, so now we have taught rooms how to have exits added to them. Go back to dungeon. Now that we have E1, we're going to go ahead and say entrance dot add exit E1, because that room entrance, this dude, has an exit added to him, E1. All right, makes sense? All right, let's shrink this guy down some. Okay, perfect. There's exit E1. All right. Now we need to create an exit E2. That guy's going to go from H1 to the south to entrance. Exit E2 is equal to a new exit to the south, and he's going to lead to the destination that is entrance. All right. And where are we going to put this? We're going to put it in room H1. We will add an exit E2. And that makes this picture correct. Oh man, do I have the... Oh man, wait. You can do it. Oh, that doesn't work. You... It'd be flipped vertically, right? Oh.
Yeah.
Oh, we can flip it horizontally. It's like a chiropractic adjustment. Oh. This guy's not paying his bill. I really thought I could. I've done this before. All right, this is what's going to happen for the time period. You need to be able to read upside down or back and backwards. All right, so deal with that. All southern facing exits you must look at in a mirror. Wait until we go east and west, it's because of a whole new problem.
Oh, yeah.
All right,
I don't know why there's not like a little rotate.
there is. Oh, hold on, I think it might be over here. Very upset with you, Apple. Oh, hold on. Dun, 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 dun.
And it's so set down.
Well, no, hold on, but I think we can roll with this. At least this will help us with our east and wests. Good enough. This is good enough because now we can go east and west. Deal. All right. So we've done our exits related to entrance. Now we also need to add a northern exit for H1, right? Leading to H2. So we'll go ahead. We'll say exit E3 is equal to a new exit to the north leading to H2. And we'll go ahead and add that to H1. So that's exit E3. All right. So I think we're good there for the H1 exits and the entrance exits. So now from H2, we need to go to the south, we need to go to the west, we need to go to the east. So we need 3 exits for H2. Who? Oh, thank you. I was testing you. You passed. E4. I'm just going to leave it blank here for a second. So I can create a, so we need 3 exits, right? 2, 3, 5, and 6. All right, so we're gonna have one going to the south to H1. We're gonna have one going to the west to H3. And we're gonna have one going to the east to H4. All right, and we're adding all those exits to H2. E6. All right. Which one's going to H1? That's E4. Nailed it. And then this one is going to be E5 to the west. Good enough.
Oh, no. Oh, no.
All right. You guys deal. All right. And then this is going to be E6 to the east. Good enough. Oh, perfect. Good enough for horseshoes. There we go. All right. So we got that. Man, this is so good. So now from H3, we need one going from the east to H2. So exit E7, close new, exit east H2. And this is H3, add exit E7. And that's going to be are we back? Ish.
Yeah.
I threw a ninja curveball there. That's the thing. This is a bad design. Apple has these like the multimedia little strip thing at the top of your that you just accidentally touch. Nobody uses that except accidentally like that. All right. So then we need from H4 to H2 to the west, right? Exit E8 equals new exit west. And it's going to head to H2 from H4. All right. And that's going to give us one of these dudes. That's E8. All right. Then we also need to have an exit to the east heading to H5. All right. So H4 heading to the east to H5. It's E9. All right. Now for H5, we need one heading from the west and one heading to the north. So west is heading to H4. North is heading to S118B. Did I make it capitalized? It just decided to make it capitalized for no good reason. All right. And we're adding both of those to H5. H5 add exit E10. H5 add exit E11. So now we have this is E11. Uh-oh. And then this is E10. Oh, I see. All right. And then finally, we need one from S118 to H5 heading to the south. Exit E12 is equal to new exit to the south leading to H5. And we're going to say S118B dot add exit E12. That'll give me that guy. All right, so now we have all of our exits and crap like that there, right? All right, and did we already set our starting room? Let's just make sure. We haven't added the rooms to the dungeon. You're correct. All right, so I'm gonna actually set my starting room. I want to say at the very end here. No good reason. That's fine. And then we're gonna say add rooms to dungeon. We'll say set starting room. We'll call this area build and set exits. And we'll call this guy build rooms. All right. Now we can go ahead and add rooms to dungeon. Our dungeon has a collection of rooms. And it has a current number of rooms, which initially starts off at 0. I'm going to go ahead and give ourselves a private function that adds a room to this dungeon. We could certainly just do it inside the populate CS department thing, but let's just give ourselves a function, pretty short and sweet. Add room. This guy will take in a room R. We'll say this dot the rooms at bucket. Current number of rooms. This dot current number of rooms is equal to the room we're just adding. And then we'll say this dot current number of rooms plus plus. We added a room, so now we have one more room. All right. And then we'll go ahead and call add room one time for each of my rooms here. Where did I say I was doing that? All right, so we'll say this dot add room for entrance. Steal this line. And then we have H1 through H5. And then finally S118B. Okay, so now we have all of our rooms. Oh, I just saw that. I already had labeled it right down here. There we go. Perfectly organized, beautifully written code. But it's undercooked. All right. So out here in main, we say create an instance of a dungeon with the maximum number of rooms to 100 for no good reason, just in case, we do an expansion project. And then go ahead and tell that dungeon to populate itself based on the CS department floor plan. All right. So when a dungeon's first created, it instantiates its collection of rooms up to 100 rooms. We currently have no rooms in there. We currently don't have a starting room. Then when we tell it to populate the CS department, we create a bunch of rooms. We create exits and associate them with those rooms. We set the starting room to entrance, which we just arbitrarily decided this is where you enter the department. And then we went ahead and added those rooms to the collection of rooms for this dungeon. All right. All right, so now we need to add a player and throw them in the entrance probably. All right, and then we need to create a couple of monsters we'll probably put that in the, let's go ahead and create our player out here first. So what's a player? Just has a name. Player P is equal to new player, and this is Mr. Gonzalez.
Yeah, I thought you were- yeah.
He's a monster? Oh, he's got to be a boss, actually, right? All right. He's getting he's getting an Oscar tank today, but he calls it an Oski tank. It's going to be Star Wars themed. It's going to have a white albino Oscar named Skywalker and a dark Oscar named Vader. All sorts of Star Wars theme. You know, Oscars get huge. They get like 12 to 18 inches. Yeah, and they eat all sorts of stuff. Anything they fit in their mouth, they'll eat. It's like a dog. He's gonna feed them like M&Ms and stuff. My wife has like a community tank with nice, peaceful fish. Now, Mr. Gonzalez. Mr. Gonzalez's fish eat Legos. All right. So we have our player. We need to go ahead and teach ourselves how to add a player to the dungeon. Probably players get added to the starting room, maybe. So that means inside of room, we can have now this is where we make that design decision. Do we have for a room, do we have a collection of monsters and a separate collection of players? Or do we have a collection of inhabitants, which is a mixture of players and monsters? Anybody have a preference and why? Go ahead. There might be some truth to that. Although, I mean, I'm not sure searching through your array of players is significantly different than searching through your array of inhabitants to remove a player. But at least certainly get you potentially looking through a fewer things. So it maybe is at least it's maybe more efficient.
Separate variables and there's 3 4 and then having so I tried to do and I couldn't quite get there was have one spot in the array B where the player was.
What I was kind of thinking is if we have them in 2 separate collections, that allows us to maybe more easily create like when you you enter a room and it says who's here, it lists the players, and then maybe also here it lists all the monsters. So you can kind of more easily just display information about the room. So with that in mind, why don't we go ahead and say private player array. Call this guy the players. This is inside a room. So every single room will have a collection of players. Private monster array. The monsters. We'll want to go ahead and instantiate them inside of room, or inside of the constructor rather. So we'll say this dot the players is equal to a new player array. See, hopefully what you're seeing here, this is where it starts getting inconvenient to use fixed arrays. Because fixed arrays, you basically have to say, I'm going to guess that maybe the most number of players we ever have in a room is coin flip. Yeah. Could be 5, could be 500, whatever you decide, right? All right. So if we had an elastic type, like in Java, we have something called an array list, which is an elastic type. We could just say, this guy is a new array list of players. Like that. And you start adding players to it, it'll keep track of who you have in there. No harm, no foul. Do we want that? Fine. All right, so we'll say player, we'll have up to 25 players allowed in a room. This dot the monsters, we'll do a new monster array. We'll also allow up to 25 monsters in a room. But now we need to also keep track of how many monsters and how many players are actually in the room. So private int current number of players. Private int current number of monsters. This dot current number of players is equal to 0. There are no players in a room when it's first born. This dot current number of monsters is equal to 0. There are no monsters in a room when it's first born. Make sense? All right. So a room in its infancy has a little container for holding exits. There's nothing in there. Has a little container for holding players. There's nothing in there. Has a little container for holding monsters. There's nothing in there. That's why we set nothing in there, nothing in there, nothing in there, and then here are our 3 containers. So we have to keep track of this extra information about our arrays, because as we put stuff into the dungeon, that's when those things change, because we have this giant bucket, but we need to remember that, oh, there's only 2 players in here. Or there's 4 monsters in here, even though there's this giant bucket that can hold up to 25 of them. All right. All right. So we'll come back on Wednesday. We'll go ahead and throw our player into the entrance. We're a little function away from that. We'll throw our monsters into a couple places, and then we're going to go ahead and allow our player to start moving around in there. Once we have that, we're going to introduce threads and have our monsters start moving around on their own in there. Okay. Questions, comments, concerns, bribes. I'll save this and put the link to the code up on Slack.